Some of you might be wondering, why do we study about simulations? And more importantly, some of you might be wondering, why are we studying about simulations in statistics class? Well, it turns out that a lot of times just looking at existing data is not good enough for understanding a particular situation. Sometimes we need to conduct an experiment, and sometimes we need to conduct a simulation. Now, it turns out that simulations are used in all kinds of areas of life. And for instance, here is the National Severe Storms Laboratory, and you can see that they have a bunch of research tools that allow them to simulate storms, okay? When firefighters are trying to fight wildfires, they use simulators to try to figure out where is the fire going to head next and how devastating might it be. And heck, even last year, before coronavirus hit us, it was predicted by a bunch of scientists that we could have a pandemic this year. An article dated February 27, 2020, talked about coronavirus simulation that went on back in October of 2019. And that particular simulation took place. It was conducted by a group of public health experts that gathered in New York City, and they did a simulation related to coronavirus 2 months before the coronavirus that caused COVID-19 emerged. I have to admit, I don't know for sure how much that helped us, but I can tell you this. The idea that we can simulate and predict things that are coming up, the idea is that it's supposed to help us to be better prepared. The other thing is election forecasts. This is the website 538.com, and one of the things that they did, in addition to all the polling, is they conducted many simulations of the upcoming election between Trump and Biden. And when they did their simulation, they simulated the election 40,000 times, and based on existing polling data, and then they just wanted to see who won the most often. And then what they say in this picture is the sample that you see here is 100 outcomes that give you an idea of the range of scenarios that their models think are possible. So anyways, simulations can be used for a lot of different things, and we're going to go ahead and we're going to begin to explore. Now, you've already been looking at simulations to some degree, but you've been doing them manually. And doing manual simulations, I don't know if you've noticed it, but it's quite a bit of work, and it can be very tedious. So we're going to learn how to use the computer to do simulations. In order to conduct a simulation using a computer, you're going to need to learn how to do a little computer programming. And I want to let you in on a little secret. All computer programming really is telling a computer how to do things over and over again for you. The reason why people learn to write computer programs is because when you write a computer program, you can get the computer to do work for you. And that's the goal. You invest a small amount of time up front to get a program that will take care of hours and hours and hours of work for you. Okay, so anyways, let's take a look at some basics for writing a computer program. The first thing I want to introduce you to is the idea of variables. And this is also a decent review for math and algebra class. You might recall that we have different variables when we're working with algebra, like x and y. So for instance, we could say x equals 5, and we could say y equals 7. And another thing that we could do in algebra is we can multiply things together. So I'm going to try something like x. In computer language, when we want to multiply, a lot of times we'll use an asterisk. So I'll say x asterisk y. Now the only thing is, in order to get the computer to show me what it's doing, or to show me whether it knows what I've told it, I have to ask the computer to tell me. So I'm going to go ahead and add some commands here that will let me know what's going on. Like for instance, I'm going to say print x, and that'll tell me what value it believes x is holding. Remember, variables are just letters that hold values. And I'm going to try print y. And then x times y really, I could just do print x times y. There we go. And we'll go ahead and we'll run the computer program and see what it says. We're expecting the bottom number to be 7 times 5, which should be 35. And voila, it worked, yay. Now, sometimes we like to do calculations on the computer, and we don't need to print the values right away, or the result of the values for a calculation. So maybe we might use a third variable, like z, and we'll set it equal to x. This time we'll try x plus y. And then instead of saying print x plus y, we'll just say print z. And this should get us 12. And sure enough, it does, so yay. Okay, now, one thing that's nice about working with computers is that when we have variables, we can make the names much more descriptive. So, for instance, if I wanted to do something like pick a number, for example, like I guess we could say random number 1, something like that. And we could say rand number 2. And then I could go ahead and print those guys. Again, rand num1 is one variable. That's a little different than algebra. In computer programming, we're allowed to have variables that have longer names. And again, but still we can do math. And one of the things when we multiply two things together, we do have a special name for that in math class, and that's called a product. So I'm going to say the product of rand num1 and rand num2 is going to be equal to the product, to the variable called product. And then I'll go ahead and I'll print that. Okay, so now I'll go ahead and hit run, and we should see 5 and 7, and we see the product, the multiplied together. Now, one of the things that happens as our computer programs get to be a little bit longer and more complicated is sometimes it's not easy to remember what all of these numbers are supposed to represent. So we're going to put in some extra stuff to make it a little bit more obvious. All right, so what kind of extra stuff am I talking about? Well, what I'm going to do is I'm going to put in a double quote, and then I'm going to type random number 1 colon space double quote. So that'll let me know that I'm about to see random number 1, and give a little space for it. Then I'll put in a plus symbol, because I want to tack that string of letters together with the number rand num. Now, unfortunately, the computer doesn't like me to tack a string of letters together with a number, so what I'm going to do is do str, which converts my number into a string. So now I've got a string of letters and a string of numbers, and I can add them together and print them out. So let's take a look and see what that looks like. And voila, there we go. I get random number 1, and it's 5. And in case you don't believe that 5 is, it's not being randomly selected. We'll get to that in a minute. Anyways, so far my random numbers have not been randomly generated. So anyways, let's go ahead and let's put some more labels on the rest of this stuff. I'm going to do it real quick while I pause the video for you. Okay, so I added some additional words and some additional plus symbols and STRs for string, and now it should look really pretty when I run my program. Look at that, boom. Now, one thing that would make this a little bit more interesting is if those numbers actually were random. So we're gonna take this one step further. Here we go. What we're gonna do is this. In this particular programming language, which is known as Python, if we want to generate random numbers, there is I think I have to do something called import random, and then there is a function that will let me make random numbers. So the function looks something like this. It is random.randint, and then I tell it between what two numbers would I like to generate my random number. So I'm going to go ahead and say 0, comma 9. And then we'll do the same thing. We'll make a second random digit for random 2. And it'll be 0 through 9 will be the possible values for the random numbers. So now I'm going to go ahead and clear off my console over on the right, and I'm going to go ahead and hit run. And we can see I did get two different numbers, a 0 and a 1, and when we multiplied them together we got 0. Let me try this a few more times. I'm going to hit run again, and I'm going to hit run again, and again, and again, and again. And every time I hit run, I do get two different random numbers. And this is the beginning of being able to create a simulation. And more importantly, if you use your imagination and your creativity, this gives you the ability to create games.